Hello everyone. So what we're going to do today is basically review for your quiz. Okay. So what we're going to be doing is I'll be posting this review material, okay, online. Make a print of it, and then what I'm going to do is to answer the ones that has circles on it. Okay. So this is practically what the test is going to look like. Okay. So if you also want, I'll post the solutions that I'm going to write on a separate sheet of paper for each of those circled numbers. Okay. So let's start with 8.1, which is defining and using sequences and series. Okay. So let's start from number one. Okay. So describe the pattern shown in the figure. Okay. Then write a rule for the nth layer of the figure where n equals 1 represents the top layer. Okay, now let's look at the top layer. Okay, so for number one, let me put it right here. Okay, so here you notice that a sub 1 has two blocks, right? That's the one on the very top. Okay, now a sub 2 or the second layer has six blocks. Okay, while a sub 3 here has about 12 blocks. And a sub 4 here has 20 blocks. That is simply by counting the blocks. But notice, okay, I can simply get the number of blocks by simply multiplying the numbers. Okay, look at the first stop. It's 2 because it's what? One side, 1 times 2. So this is actually equal to what? 1 times 2. Okay, 6 is the same thing as what? 2 times 3. Okay, 12 is actually equal to what? 3 times 4. And the 20 is actually what? 4 times 5. Okay? So basically, you notice a pattern. So when A is 1, it's 1 times 2. A sub 2, 2 times 3. A sub 3, 3 times 4. A sub 4, 4 times 5. So basically, if I'm going to choose A sub n, okay, to find the rule for the nth layer, okay, so that would be what? N times, it's always 1 plus the previous number. So n plus 1. So if I simplify that, a sub n is actually n squared plus n, okay, which is my final answer. Okay, that's number one. Okay, let's move on to number three. Okay, so I'm gonna put it right here. Number three. Okay, so number three tells us that we write the series using a summation notation. Okay, so again, summation notation again would now be the summation, okay, of the rule, okay, that starts. So since it's going to start from n equals 1, now since this one is dot dot dot, okay, which means it's going to be infinity. Okay, so all we got to do is figure out what a sub n is. Okay, now let's look at the numbers. Okay, so here a sub 1 is 0. Okay, a sub 2 is 2. Okay, a sub 3 is, looking at this, 6. And a sub 4 is actually what? 12. Okay, so if you notice, again, let's make it a pattern from here. Okay, remember 12 is what? 3 times 4. 6 is what? 2 times 3. Okay, 2 is equal to what? 1 times 2. And then 0 can be typed in as 0 times 1. Notice again the pattern. Okay, so which means if I'm going to type a sub n will still be equal to n times n plus 1. Okay, so if I'm going to type the summation notation would now be the summation of the rule, which is n times n plus 1. Okay, starting from n equals 1 from here, and then it goes on to infinity. Okay, so this is your final answer. Okay. Next, we have number 4. So it's number 4 in there. See that? So here, I'm gonna put it right here. Okay. So let me put it in this way so that we have some space. Okay. So I'm gonna put number 4 here. Okay. So number 4. Okay, uses a calculator, but we have to lay them down. So it's the summation of 9 minus I to the third from I equals to 2 until what? 7. Okay, so basically you're substituting I from 2 to 7 and then adding them all up. So this is just going to be equal to, okay, 9 minus, let's start with 2, so it's 2 cubed, plus 9 minus 3 cubed, plus 9 minus 4 cubed, plus 9 minus 5 cubed, plus 9 minus 6 cubed, plus 9 minus 7 cubed. Okay, so notice I'm just simply adding up all of these. Okay, and then I'm just gonna put in all the values. So here, this is 2 to the 8, 9 minus 8 is 1. Okay, then I'm gonna add them all up. So use a calculator for this. So what I'm gonna have would be negative 80 for this one. For this one would be 64, and my 9 minus 64, negative 55. Okay, and this is 9 minus 125, so that's going to be negative 116. And then plus 9 minus 216, so that's going to be negative 207. Plus, okay, the last one would be negative 324. Okay, so if I simply add them all up, I get an answer equal to negative 729. Okay, my final answer. Okay, next, let's go to 8.2. Okay, so 8.2 is about arithmetic sequences. Okay, so here I'll have 8.2. Okay, arithmetic. Okay, so let's start with number 10. Okay, number 10, find the rule for the nth term of the arithmetic sequence. Okay, then graph the first 6 terms of the sequence. So I'm gonna ask you to do the graph, but instead I'm gonna ask you what the rule is. Okay, so number 10. Okay, right there. So a sub 14. Okay, from here, that one, which is actually equal to 42, and b equals what? 3. Okay, so again, you're gonna use the formula a sub n equals a sub 1 plus n minus 1 times d. So just simply plug this in. So first get a sub 1, right? So this is just going to be a sub 14 equals a sub 1, because you don't know what a sub 1 is. That's going to be 14 minus 1, which is 13. Okay. And then times d, which is equal to 3. So you have now a 14 equals a sub 1 plus 30 times 3 is 39. But a 14 is what? 42. So 42 equals a sub 1 plus 39, which means my a sub 1 is actually what? 3. Okay, so if I'm going to put that in, so the formula, which means a sub n now is equal to a sub 1, which is 3, plus n minus 1 times 3. Okay, so that's going to be a sub n equals 3 plus 3n minus 3. So 3 minus 3 cancels out. Therefore, my rule is actually what? 3n. Okay, final answer. Okay, so next, and the problem is number 12. Okay, so I'm going to write it back. So number 12, find the sum. Okay, so let me put it right here. Sum number 12. Okay, now remember how do you get the sum? the formula for the sum will be what? S sub n equals a sub 1, okay? So n over 2, n over 2, I'm sorry, n times a sub 1 plus a sub n divided by 2, okay? That's the formula, okay? So we're going to use that. So for the sum, okay, what you have is actually the summation of 2 plus 3i, okay, from I equals to 1 to 36, okay? So all we got to do is first find a sub 1 and a sub n. So a sub 1 would now be a sub 1, substituting 1 here, okay? So that's going to be 2 plus 3 times 1, that gives me 5. And then the last term, which is 36, so that's going to be a of 36 equals 2 plus 3 times 36, okay? So that's going to be 108 plus 2, that gives me 110. So, which means my n here is also what? 36, because it's 36 terms. So basically I have all of them. So all I got to do is just simply put in the formula. So sum of the 36 terms, that gives you 5 plus 110 divided by 2, right? Times what? Times 36. So if I compute that, use a calculator, okay, S36 is equal to 2070. Okay, that's number 2. Okay, next, let me do 13. Okay, you take a job with a starting salary of 37,000. Okay, your employer offers you an annual raise of 1,500 or 1,500 for the next 6 years. So write a rule for your salary in the nth year. What are your total earnings for the 6th year? So basically, okay, so first you need to get the rule. And then after getting the rule, you get the sum, right? So here, in number 13, okay, put it here. Your first term is your starting salary, which is 37,000. And then you have a yearly raise of 1,500. So that's going to be your, okay? So you can easily get a sub n here, right? So a sub n is equal to 37,000 times a plus n minus 1 times d, which is 1,500. So that's going to be 37,000 plus 1,500 and minus 1,500. So that's going to be 1,500 and minus 37 minus 1,500, it's 35,500. Okay, so this is your case again. That's one of the answers. Okay, now you're getting the sum for your earnings in 6 years. So you're getting S of 6. So again, first get a sub 1. A sub 1 is actually what? 37,000, right? Plus, substitute when n is 6. So 6, so substitute here, 6 times 1,500 is 9,000. 9,000 and then 35,000. Oh, sorry, this is plus. Okay, so 9,000 plus this would be 44,500. Okay, divided by 2 times 6. 6 is the number of years, right? The sum of 6 years. So if I use a calculator here, S of 6 would now be 244,500. Okay, so this is the final answers. This and this. Okay, so next would be 8.3. Okay, 8.3 would be analyzing geometric series. Okay, so there you go. So here we're done with arithmetic. Okay, we're gonna go geometric series. Okay, so again, geometric series, I'm going to put it right here so that we have some space. Okay. Write the rule for the nth term of the geometric series. Okay. Then I'm not going to ask you to graph. So let's start with number 16. Okay. So 16, a sub 5 is 162. And then r equals negative 3. Okay. So again, the formula is a sub n equals a sub 1 r raised to the n minus 1. So I'm just going to simply substitute that value. A sub 5 would be 162. We don't know what a sub 1 is, right? R is negative 3. Then since n is 5, 5 minus 1 is 4. So we get now 162 equals a sub 1 times 81. So if I divide both sides by 81, I get a sub 1 equals 2. So I have now my 2 and my r, right? There you go. So therefore, a sub n now is actually equal to 2 times negative 3, which is your r, raised to the n minus 1. Okay, final answer. Okay, that's number 16. Okay, next, 18. Okay, I'm going to write it here. Okay, sum. Okay, so again, the sum sub n would now actually equal to, remember, it's a sub 1, 1 minus r raised to the n over 1 minus r. So you need to have two things. Okay, so the equation is, let me write this down, summation of 5 times negative 2 raised to the I minus 1 from I equals 1 to 9. Okay, so looking from here, a sub 1, it's the first one, which is actually what? 5. Okay, and my r is the one that's being raised to the exponent, which is negative 2. So I'm going to use that to substitute in here. And then my n is actually what? 9. Because it's from 1 to 9, right? So s sub 9 is actually equal to a sub 1, which is 5 times 1 minus negative 2 raised to the 9 over 1 minus negative 2. Okay. So use the calculator here. You're going to have an answer of s sub 9 equal to 855. Okay. So that's geometric series. Okay. Then we have, again, infinite geometric series. That's 8.4. Okay. So let me put it in here. So remember, this one is kind of like easy because it falls on just simply one formula. Okay. So for this one, okay, infinite geometric series. Okay. I'm going to choose number 20. So number 20 right there. Find the sum of the infinite geometric series. Okay. So the formula for the sum is actually equal to a sub 1, okay, over 1 minus r. You just have to know what a sub 1 is and what a sub r is, or what r is, I mean. Okay, looking at number 20, first term is negative 2, right, from there. And then r is actually equal to what? Negative 1/4. Okay, so you actually multiply negative 1/4 every time. So you just have this two, plug this in. So you get now s is equal to negative 2 over 1 minus negative 1/4. So that's going to give you negative 2 over 4 over 4 plus 1 over 4. That's going to be 5 over 4. Or simply negative 8 over 5. Okay, there you go. And then 21, put it right here. Okay, write the repeating decimal, 0.12, 0.12, 0.12, 12, 12, 12, 12. So it's going to be, okay, the decimal is 0.121212 2, and so on, which is actually equal to what? 0.12 plus 0.0012 plus 0.000012, and so on, 2's by 2's. So notice here, my a sub 1 is actually what? 0.12, right? And then my r is actually 0.0012 divided by 0.12, or simply 0.01. Then just simply substitute the formula. So that's going to be S is equal to 0.12 over 1 minus 0.1, 0.12 over 0.99. Okay, there you go. Or simply 12 over 99. Use that fraction. Lowest terms, both are divisible by 3. This is going to be 4 over 33. Final answer. Okay, and last one, which is about recursive sequences. Okay, where is that? Okay, there you go, here. So this one is recursive. Okay, recursive sequences. Okay, so here, write the first 6 terms of the sequence. Okay, the first one. Okay, so first one, number 23. Okay, the first term is actually what? 6, right? And then to get to the next term, we see that, okay, the previous term is being multiplied by 4. So just multiply by 4. So 6 times 4, 24. Times 4, 96. Okay, times 4 is 384. Times 4 will now be 1536. Okay, so continue on. Okay, so 1536 times 4. Okay, so that's going to be 6144. Okay, so that's the answer for number 23. Okay, okay, now write the recursive rule for the next one, number 25. Okay, so this one is actually what? Again, this is a geometric series. First term is actually what? 9. And r is actually what? 2 over 3. Okay, so if I'm going to write the recursive rule now would be a sub 1 equals 9. And then to get to the next term, you multiply 2/3 to the previous term. Final answer. Okay. Next, write an explicit rule for the sequence. So number 29. So here a sub 1 is 4. And to get to the next term, you add 26. So that's your D. So a sub 1 is -4. And D equals 26. So all you got to do is to simply use the formula. Because you need the rule, right? So a sub n equals -4 plus n minus 1 times D, which is 26. So that's going to give you a sub n equals -4 plus 26n minus 26. So a sub n equals 26n minus 30. Okay? Let me put it out here. There you go. Okay? So 426, just simply plug it in. Okay? And the last one. Okay, 32. Let me put it over here. Okay? Number 32. Okay? So a town's population increases at a rate of 4% per year. Okay? In 2010, the town had a population of 11,120. Write a recursive rule for the population P sub n of the town in year n. So that n equals 1 represents 2010. So here, you know that the first term, because it's a recursive sequence, right? So you're going to have 11,120, right? Notice it's increasing at a rate, so which means it's being a geometric series, okay, by 4% per year. So which means you are actually increasing it by 1.04. It's 100% plus 4%, right? So your P sub n is actually equal to 1.04 times p of n minus 1. So they go together. So this is your first emitter. Okay? So I'll post this on the website. Okay? And then you can use the discussion on how I do this. Okay? That's it.